welcome everyone to BC Energy Code, the handbook for building officials. My name's Andy Christie. I work with City of Kimberley. I was part of this handbook creation during the summer. It was kind of interesting project to happen. With us today is going to have Don Peaty from the province, BSSB, and James Higgins, sort of the brainchild of it, the creator of this handbook, sort of helping us through it all. He's going to kind of walk us through a general overview of step code. For so those of you that don't know anything about step code, which I doubt anyone in the room. Does anyone not know about the BC Energy step code in this room? Everyone does, I figured. Is anyone implemented it in their community already? See, there's a few already. That's good. Without further ado, I'll toss you over to James here.
Thanks very much, Andy. Good morning, everybody. Really appreciate you all joining us here. Big crowd. It's excellent to see so many faces interested in this. So this is obviously a presentation with the title of the same handbook that you've got in front of you. If you don't, it's up here at the front. More or less a summary, the same content with my commentary. And then throughout, I'll definitely be open to questions, by all means, from throughout the room. And then we've got Don and Andy who can chime in. I might punt things off to them if I'm not totally sure. And we can keep this kind of as a discussion to say, you know what, we're talking about implementation, we're talking about the process. There's lots of concerns, questions, experiences. So by all means, feel free to pipe up or put your hand up. If we're having trouble hearing, we might run the mic around. But if you can speak loud enough, I'll repeat, or whoever's up here will repeat your question for the audience, and as well, I think we're on camera. So without further ado, I'll proceed. So this handbook recently released. Actually, we just updated it and printed this version, given some changes at BOABC. And it's a fairly succinct guide to implementing the step code, all the different considerations and the new processes and compliance rules that have to be implemented. So this is definitely geared towards you as the building official, whether you're reviewing the plans on site, but it's also the back end. What is it that you're basing your compliance on, the policies, the bylaws that have to be in place to make this as easy as possible. First off, many thanks to all the contributors. We had contributors from across the province, lots of building officials that joined us on the calls. We went through the guide content in its draft form, lots of feedback, and it helped us form the guide that you see in front of you and obviously that you'll see up here. Of course, special thanks to Andy Christie, and then not listed, Don Peaty's joining us here. And BSSB gave us a lot of good kind of, like I said, background info for why we can implement or have our own implementation process apart from the code, right? So we have the code minimums, but now we have to implement it, and that's where the building officials come in and the authorities have jurisdiction. So there's basically 3 parts to this guide. And again, fairly succinct, an overview of the BC Energy Step Code, something that I'm sure you've all heard of at least and are aware of, but I think does a fairly good job of summarizing it well. And I'm going to go through it so that we're all on the same page. There's terms, there are building energy performance metrics that the Energy Step Code uses. Maybe you've heard it, or you've heard it being described, maybe a new perspective from me. We'll then move into the outline of the new processes and the compliance and the roles. So we've got, obviously, you as the building official. We've got the designer, whoever that may be. Maybe it's the owner or the builder, or there's an architect. And we've also got the energy modeler, which is a fairly new, potentially a new member of the team. And then, of course, the builder. So that's the kind of the meat and potatoes of this guide. The last part is basically a summary of what it is that the Building Energy Step Code, the BC Energy Step Code is aiming towards, and what the information that you can use when you're reviewing these submissions and on site to help you understand energy efficiency and the goals of the BC Energy Step Code. So it's kind of a background on the principles of high-performance buildings. That's not to say that every step code compliant building is a high-performance building, but the goal is that at step 5, we have some fairly high-performing buildings. There's some chairs coming in at the back for those standing. Hopefully we can make room. I'll go through it. I won't be going into too much detail on the principles because that's something you can easily review, and we don't really have time to get into it, although I'm really happy to talk about it, all kinds of great technical info in that last section. You'll see me also reference the appendices, which are, there's two. There's Appendix A, which is the compliance forms, kind of example compliance forms, and then Appendix B, which is actually the step code metrics pulled from the code, although stay tuned, there's code updates coming. So the BC Energy Step Code, I'm sure you've seen this or a similar slide many times. In a sentence, it's part of the BCBC that provides the performance-based path to support a market transformation from current energy efficiency requirements to net zero ready buildings by 2032. So as you can see here, it's a progression of energy performance up to step 5 for part 9. And it's a series of increasingly stringent requirements on energy use, thermal energy demand, and airtightness. So this is the first kind of reference to the metrics that are used for assessing the energy performance of the building. And of course, the big thing, or one of the big themes you'll see is the consistency across the province with at least the technical building requirements. So we know that everybody is aiming for compliance with the BC Energy Step Code, rather than what was arguably before maybe different systems, different approaches. This one at least brings consistency. Now, that's not to say that, like I said, the compliance is the same. There's different processes that you can implement, but at least the technical requirements are more or less aligned. So part 9 has the 5 steps, with step 5 being the most stringent. Step 4 and 5 are kind of called the upper steps, and step 1, 2, and 3 are the lower steps. What's not included in this handbook and in this presentation is a direct reference to part 3 compliance. It's a little bit more complex and not something we can really cover in this session. Happy to maybe answer some questions about it. Maybe there's things you're thinking about for part 3, but obviously a completely different system where we have potentially, well, in almost every case we'll have either an architect or an engineer, and we have different requirements, and that only goes up to step 4. So in terms of today, for the BC Energy Step Code, we understand that the current step 1 of the BC Energy Step Code will become the code minimum by 2022. At least that's the current understanding. And there's a progression as they become the code minimum, leading up to step 5 in 2032. But the big point here, and you can see that in that third point, is that it actually is available, because it's part of the BC Building Code. It's available to any designer builder as a compliance pathway, regardless of the local jurisdiction's implementation, at least in theory. So the idea here is that if you seek to comply with step code and maybe step 4, step 5, you can, regardless of what the local city has as a bare minimum. And I mean, the reasoning for this, obviously, marketing, energy efficiency as a goal in general, but also getting ahead of the curve, right? To say that you can be ahead of the code and be ready for it when it comes into play. What that means is that, I mean, regardless of whether BC Energy Step Code is a minimum or currently implemented in your jurisdiction, it may still come in as a application. Not that often, maybe, if it's not the code minimum. We know that the code minimum is basically what most people go for, but it's still a possibility. So it's good that you guys are here. It means that you're ahead of the curve if you haven't implemented it yet, and you have the opportunity to kind of get ahead of it with your process and compliance. The Energy Step Code website, I've listed it up there. You've probably seen it. It's an absolutely excellent resource. It's got all this handbook and all the resources that are listed and produced as part of the implementation from across the industry. And so you can see there's lots of resources that I may mention and may not. By all means, take a look, and you can kind of get more info on what I'm talking about here. The idea, of course, with the BC Energy Step Code is that we have this increasing improvement in the building energy performance. And we're calling it kind of a practice, say step 1, step 2, step 3. We now have the ability to progress with the technology, and practice in quotations, of course, because it's a real building and it's a code-compliant building, regardless of the step. So that by the time we have these fairly stringent energy code requirements, we are ready as an industry. So we have as we build, we have increasing maturity in the market pricing and the technology. That's a big one, especially we find for certain mechanical systems. Making sure that we have more than just 1 or 2 manufacturers who build the products that we need to meet the requirements. Airtightness testing and energy modeling, those are 2 big steps. I'll talk about that. We need to have capacity for that across the province, and we're building that. And then the knowledge and the skills to actually execute it, both for the designers and the builders, elevates the quality of the construction and the understanding of this concept. So what you see at the bottom there is actually it's actually an example of the progression, not necessarily the only way, although it's probably one of the most efficient, and from what we've seen, by all means, the best way to go. A enclosure-first approach where you actually improve the energy performance by making it more and more airtight and thermally efficient. In addition to obviously other energy performance improvements, better mechanical systems, but this is kind of the baseline approach to say we'll make it better so that it doesn't need as much energy, regardless of how efficiently we can produce that energy. I'll mention this enclosure-first approach a couple times, but it's more of a, like I said, it's not strictly BC Energy Step Code, lingo, if you will. It's actually separate from that, but it helps us to reach the BC Energy Step Code. So as I said, the energy modeling and the airtightness testing are the 2 big kind of new steps in this construction process. Whereas before we went from building permit to construction to closeout, really straightforward, right? It took no problems. Everybody had all the information, stamp it, everything's good to go. No, it's not that simple anyways, but before we get to construction, the design is a lot more sensitive now. So the design includes energy modeling of the building. And that, of course, requires either, I'll get into this, energy modeler or an actual uppercase energy advisor through the EnerGuide system. And then during and at the completion of construction, airtightness testing. Again, completed by either an energy advisor or airtightness testing contractor. Those 2 are big parts of this compliance process and the construction and the compliance as well. So as you see here in the orange, it's actually step 1, and that is the kind of the first go. You have these 2, you have airtightness testing, energy modeling, and it's again part of the compliance. But because this is the first step to get everybody on board, the process can kind of proceed as long as both of these things are finished. And I'll get into this a little bit. Basically, it allows for again, practice and the compliance to occur without having to have harsh penalties, if you will. Beyond step 1, we have step 2 to 5, and basically step 2 plus. The same 2 requirements for energy modeling and airtightness testing, but what's important here is that the airtightness testing, especially now, plays a role in the compliance, where if you aren't as airtight as intended, as designed, you're having to make changes according to the as-built airtightness. So airtightness in general, I'm going to say airtightness a lot this morning, and I apologize. It's a bit of a mouthful. Airtightness. It plays a big role in compliance, and it's fairly complex as we proceed, as it kind of gets implemented, because it's something new as a technical requirement, but the compliance process for implementing airtightness is also a bit complex. Hopefully I can break it down, but again, there's the resources outside of my presentation, and obviously the handbook you've got in front of you will help to clarify it a little bit. And so as I said here, if you're failing after step 2 onward, you're having to make changes as part of the compliance. Okay, so that's the overview of the BC Energy Step Code, and by all means, any questions on it, feel free to raise your hands. The process now has to be, well, I should say, this is where the process comes in. You have, the authority to review it, and obviously to accept the submissions that include this work. So the first one, of course, is energy modeling. You obviously aren't doing the energy modeling, and you aren't the energy modeling experts. And so it's really relying on this, the third party, this designer, either, like I said, the energy modeler or uppercase energy advisor, to provide the information and do it correctly. And so that energy modeling process starts with all of the building information. We've got the size, shape, enclosure, the R values, U values, mechanical systems. It's all put into, most commonly, the program used is HOT 2000. Basically, it's a glorified Excel spreadsheet. Put in all of the numbers, and then it turns out basically what the modeled energy performance of the building is, and that's used to show compliance. I'll get into this a little bit more, but we have the metrics, the TEDI, the MUI, and the percent better than reference. And then one other side benefit is that this energy modeling also helps with the mechanical sizing and the mechanical design, at least hopefully, because it has got the information that the actual mechanical designer or mechanical contractor can use for sizing equipment. Side point, but still a benefit. The other part of this, of course, energy modeling is occurring at the design phase. And one quick thing here, the air leakage rate is assumed at this point. This is where it obviously becomes really important. The air leakage, air tightness, is part of the building completion, and we can't guarantee it. And I'll get into this a little bit more. It's not as if you can prescribe it, well, you can assume it, you can design for it, but the air tightness has to be achieved overall, and that's shown through air tightness testing. So you've probably seen this, and if you haven't, it's a relatively straightforward test. You pressurize or depressurize a building using a big blower door. And that blower door then measures the airflow into or out of the building at a certain pressure and is able to calculate how much air leakage is occurring. And this is a quantitative measurement of the air tightness of the building. Happy to get into air tightness in general, but from our perspective, one of the most important things for the building enclosure, actually regardless of energy, although it plays a massive role, the airtight building is already well on its way to being a high-performance building. What you'll see is that this testing can come into play even before we get to completion to kind of help to show that we're on the right track. I'll show that in a little bit here. And this air tightness testing is actually, if you have an energy advisor, I'll describe what the difference between an energy advisor and an energy modeler is. But if you have an energy advisor, they're doing the air tightness testing as well, or there'll be potentially other providers of this air tightness testing. I haven't seen yet, but potentially builders, although it's not likely that they'll get into it. It's just very beneficial to be able to kind of understand how it works and use the information that it spits out. So we then use that information to measure against the metrics. We call them the step code metrics. And I've got it italicized. Again, there's a glossary, I think, in the beginning of section 1, but I'm not totally sure, that gives a quick summary or a quick definition of each of these terms that are related to the BC Energy Step Code. So 3 basic categories: the air tightness, the equipment and systems, and the building enclosure. And I'm going to go relatively quickly through each of these metrics, but it is helpful to understand how they come into play, and they all have to be complied with. Okay. So air tightness, referred to as the air change rate, or ACH, or air changes per hour, the ACH. That is the hourly airflow rate divided by the building volume. So, as I said, it's quantitative measurement of how much airflow is going through this building when you have it at the specified pressure compared to the size of the building. So we call that normalizing it over the size of the building. And each of these metrics are, and I'll get into that a little bit, but essentially we can make sure that we're comparing apples to apples regardless of the building size, although there are some ways to, categories of building size for some of the metrics. But it's better that way because we're then making sure that the size of the building is accounted for in our compliance and in the metric. So with this one, the lower the air change rate, the better. Now this isn't how air leaky the building actually will be, obviously, while being operated, but it's a measurement at 50 pascals, which is not a huge pressure, and as I said, the lower the better. The step code, it talks about 2.5, 3.5, 4.5 air changes per hour, but it does go down for the higher steps. We're down to 1 air change per hour. That means that within 1 hour, all of the air in the building is replaced with this fan. Again, part of the test, not part of the operation of the actual building. Okay, so airtightness, we're seeking as airtight as possible. The equipment and systems, there's two metrics. The mechanical energy use intensity, the MUI, that's the total yearly mechanical energy usage in kilowatt hours per year, divided by the area of the conditioned space. So this isn't the volume, it's the area, but it is normalized by the building size. Excuse me. And that's measuring the equipment, the power consumed by heating, cooling, ventilation, fans. There are things that are excluded, call them the base loads, because in energy modeling terms, there are various power usage categories that don't really contribute, and it's not fair to count them. We can talk about that if you're curious, but essentially it's simplifying it so that the actual usage from the occupants doesn't play a role in what the building is doing. The other mechanical equipment and systems metric is the percent better than reference. And this is a short way of saying it's better than a reference house per the energy modeling. You can see the formula down there, but we're looking for a higher percentage improvement. So we start at 5, 10, I think it's 10%, and then we improve it to 20, 30, 40, 50% better than the reference house, and I'll talk about that as well. So we have a current code minimum and the steps that reference that and improve upon the energy usage. The reason that there's 2 here is essentially to give options, but there's a fairly straightforward way of how this is shown. And again, these metrics are important to know, but it's not necessarily something you'll be calculating directly, right? We're going to be relying on the design and the energy modeling for that. The third category, I'll just go back here. We've got airtightness, equipment and systems, the building enclosure. I obviously a building science technologist with RDH Building Science. I very much focus on the enclosure. It plays a big role in this whole process. And the thermal energy demand intensity is how we measure it, or TEDI. So this is the net yearly thermal energy demand divided by the area of the conditioned space once again. And the net is important because it does take into account solar heat gains that can offset some of the heating, the mechanical heating. This is again all done through the energy modeling that can produce the numbers that can be used to calculate the thermal energy demand intensity. And essentially, the lower the better, or the more energy efficient the enclosure is, the lower the thermal energy demand intensity. Fairly straightforward as a concept. Of course, the measurement requires all kinds of modeling and inputs. Alrighty. Any questions so far on metrics, the 3 categories? I think it'll become a little more clear when we show the kind of the process and how it works, but by all means, feel free to jump in. Okay. So then we move on to the process, compliance, and roles. So all of this, the airtightness, the energy modeling, all of the metrics. All that means essentially is that we no longer have these Section 936 minimum R values based on, or minimum U values and mechanical efficiencies based on the climate zone that you're in. So whereas before we were referencing the prescriptive R values, making sure that they match, relatively straightforward, and it's still a part of this, it's still a part of the compliance review here, but we now have fairly complex submissions, at least potentially, that have to account for all these metrics. And because it's, again, performance-based, so we're quantitatively measuring it rather than just using a prescriptive number and meeting that, we have to be able to ensure that we can actually be confident that those numbers represent the building itself and that they're going to meet the BC Energy Step Code. So 2 points here. You'll see this in green, and the green boxes will keep showing up. This is where it's kind of beyond basic code minimum. We now have these kind of pointers and recommendations as part of the process that you can be implementing. Because in fact, the BC Building Code, it only goes so far for compliance. It doesn't lay out exactly how the compliance process has to work. There's a couple of bare minimums, but it's really up to you to be able to implement the process to make sure that you can be confident in the submissions and then, of course, the building at the end. So Division C, subsection 2.2.8, that actually outlines the minimum submission requirements, and there's a couple things I'll talk about. Basically, what you have to show in some sort of report based on the energy modeling. And then this is an important point, Section 743 of the Local Government Act. So it provides called statutory immunity for local governments that approve the submissions from professional architects and engineers, but doesn't have that immunity for non-professional confirmations of compliance. So this is probably something we can discuss and get into. It's up there as a maybe to prompt discussion, and we would talk about it at the end, but it means that we can't be relying on a stamp necessarily for these submissions if it doesn't include somebody from a professional organization. That's not to say that energy modelers, and in particular energy advisors, aren't seeking to provide or organize in some way to be able to provide some sort of assurance that obviously building officials can rely on or can be more confident in. But for the time being, I just want to make sure that that's clear that we aren't getting these submissions from architects or engineers who are stamping it. So we have to be, as I said, you have to be educated on what this entails so that you can make sure it meets the requirements. So the actual flowchart, it's in there as well. It's fairly complex. I've got it here as a starting point, but you can see lots of back and forth, 3 different categories. We've got the energy modeler, the owner, builder, designer, whoever that is in the middle there, and then you as the building official at the top. And I'm going to kind of go through a lot of the basic points that each of those steps entails before we dive into this flowchart. Again, a recommended flowchart, you can see up there, not the only way to do it, but it does encompass a lot of the steps that should occur. Don't necessarily have to, but they should occur for this to be a robust system compliance for showing compliance. So energy modeling compliance, the information is being provided by the energy modeler or the energy advisor, and the goal, of course, is to show that it matches the drawings and specifications. If we've got R30 walls, we want to see some sort of indication in the drawings and the specifications that the walls are in fact R30, that at least that has been coordinated. And it goes for all the enclosure assemblies, as well as each other part of the building. And what's important is that this energy model is, and the compliance report that's generated from this forms the basis for our code compliance. We now are looking at different R values, airtightness, mechanical systems that aren't necessarily aligned with what was previously in the code, the original 936, 936.2 to 936.4. We now have new numbers, and those basically form the basis for matching what's shown on the drawings and then eventually on site. And the reason, if something is, if something is not compliant, that it's got to match that, or it has to be rejected. So the pre-construction compliance report, again, shown in green here because, in fact, this is something provided by the energystepcode.ca website, as well as the as-built compliance report. They're both really useful tools for the designer, the energy modeler, to essentially provide all of the information that their energy model includes and show that they meet the BC Energy Step Code. As I pointed out, the BCBC, the building code, has a list of the basic requirements that have to be submitted, and this pre-construction compliance report includes all of those. So we now have an organized and uniform way of providing it. By all means, I recommend it as a basis for this pre-construction, and then it becomes part of the closeout in the as-built. This is a second part, the same information, but you're making sure that where changes have occurred, they're accounted for in this as-built. We'll talk about this. One other point here, again, a note on qualified professionals and certifying the submissions. It may become necessary in certain select circumstances that you require a professional oversight of a submission. If it's, let's say, too complex, or it's something that's seeking a very, very high energy efficiency. It's not every time, and it's not intended to be the go-to, but we've seen compliance processes that involve where there has been issues or where there's something that has to be confirmed further, an engineer has to sign off on the submission. Our goal with this guidance is to avoid that as much as possible. If you can be educated enough to be able to make the call on compliance, then we don't have to include professional organizations in Part 9 construction. And that's definitely a goal of everybody here, because it then becomes less and less Part 9. Now, that's not to say you don't have energy or engineers already anyways, structurally, but it'd be ideal to be able to have this system work apart from the professional organizations. Separate discussion, but it's important to point out. You do have the authority to implement that. Yes, question?
How do you expect that expectation when there's so much reliance on the functionality of mechanical systems, also with the enclosure first policy for everything to work together? There isn't enough resources in a lot of the municipalities that have that expertise to say, hey, we've gone over a number of times, and basically what was spec'd by the advisor and what's actually installed do not align.
Mm-hmm.
I still think that there's a big disconnect between the province's perspective on this and why it isn't actually looked at as just prescriptive measures that will still meet the net zero requirements.
Yeah, that's a great point. So if I've heard you right, because of this system being performance-based, we have a lot of inputs, a lot of design that has to occur and work together, rather than necessarily following prescriptive requirements that are relatively more straightforward and we can be a little bit more confident in. And so, I mean, I'm happy to have more input here, but from our perspective, I think that it's 6 and 1/2 dozen, that if we have the prescriptive requirements, they work fairly well, and it's something that's maybe code minimum, but if we can improve upon the design process, then we can have a better product. And it's not to say that it'll work better, but it's hard to say that the code is always the kind of the something that can be relied upon to do the same thing, if that makes sense. I mean, it's not that the code worked every time either. I think, though, you bring up a good point that if we can have, and this is where we see energy advisors coming in and playing a big role. They're not engineers, they're not architects, but as energy advisors, they are, and we'll get into this, they have oversight from well, they've got quality control in their system as well, and that allows for kind of a third-party review to make sure that it's got some sort of assurances, if not professional liability, but at least something beyond just designing and hoping. I think that we want to see more and more energy advisors, and then of course energy modelers, lowercase energy modelers, improving their the quality of their work as well. By all means, if you wanted to jump in, I proceed, but.
Hello? Oh. just in Kimberley, I've been doing this for a couple of years now, definitely not an expert on it, but the comfort, it's a moving target for performance-based, and a lot of inspectors, at least in the zone, when I go to zone meetings and speak to it, there's not a lot of comfort in it because you feel like you're maybe losing a role, or like the prescriptive is sort of a lot easier when you're on the ground to inspect a home. When you have something that is inherently abstract, like airtightness, and all the inspectors in the room might inspect, say, at the insulation, vapor barrier, air barrier stage, there's probably very differing approaches when it was prescriptive versus performance. Rattling tight for one inspector might be, good enough for another inspector, versus another inspector might want, a lot higher level of physical airtightness. But until you actually test it and standardize it, there's no comparing apples to apples. So every jurisdiction would be apples to oranges to watermelons to melons. It's just, you can't have a comparative approach with prescriptive for something like airtightness that is pretty much a moving target. And almost every house I have a pre-construction report, by the time it gets to final, the house looks nothing like it did in the pre-construction report. And I make it mandatory to do mid-construction tests, just so the builders actually have a gauge of where they're at before they drywall. Because I find it very impossible to fix when it is, I have a level that they have to attain. And if they don't, then it's a notice on title or worse for the builder. They have to tear apart the house and fix it if they want. And, councillors and mayors have a real apprehension to, mandating this step code just based on the developers being gun shy to it, or, not having really a grasp of it yet. And so I think it is, the reliance on the energy advisor is very important, and you have to get comfortable with it. It's just another balance and check, like an architect schedule would be, or an engineer schedule. One sec. And I think once you get comfortable reading the reports, knowing what to look for on site, and if there's changes, like they add a window, they always change the house design on the fly. It's just, when it's prescriptive, you just roll with it, and it's, who cares about an extra window, or they change the R value there, or they add a feature wall over there, or they add more glass. But performance, it makes a huge difference, especially if there's a target to meet. But I'm finding almost every house that I've had in Kimberley has actually achieved higher performance than they did at the pre-construction stage and then at the final report. Question?
I haven't, excuse me, I haven't been on a step code committee relative to all of this right now, and to give some positive information relative to where we're going in that regard, there is going to be a distinct, how should I say, distinct change to how we do our business. Previously, before, we've all done it by prescriptive, we all know what inherently, we all know the value, we know the home. But what's going to happen is we will perform space. We're going to be changing that philosophy to use different components in the system, different airtight, achieving the goal of the steps and the levels. What's going to happen as a result of that is we're going to have to place more reliance on someone else. It's a little bit different from what we've always done in this business. So where we brought into play with the use of the step codes and the adoption of it, there has been, in my opinion, one practical that we couldn't go over in the beginning, but I do see a way going forward in terms of the industry. All of us in the industry are trying to change and better for everybody in that regard. Right now, we've brought in what's called compliance reports. All of that said, somebody has to give us a piece of paper at the moment. But based on the reliance of doing some computer programming to approve the computer program. That's it. Who that person is at this moment, we don't have true justification through the code process as a legality as to say who does this information. What they're trying to relate there in terms of the section 7.3 and those other things with the green box is to highlight the fact that we don't have presently in our system a ways and means to have somebody give us that piece of paper that we can now rely on no differently as we have done before with professional architects and engineers. Where we're going with this in terms of the step code committee and where we're going forward is to actually take the ability to actually semi-professionalize or professionalize, however we achieve it, to semi-professionalize the role of an energy advisor. There's 3 or 4 different component organizations out there that have people that do it. They do vary between what they do. And so right now we've created a white paper we're trying to take to the province and the higher levels of the step code committee across the province to be able to come back to them and say, we need to look at doing this to make this much better of a system for us down the road. What's going to happen? have that built into the system yet. So the problem, what's gonna happen is that, we did point it out in some of your programs, each jurisdiction is going to have to come back and say, how do we implement this? How do we enforce this? How do we ensure that we get this level of performance in the building that we're looking at? So each jurisdiction may have to write its own separate bylaw, own separate policy procedure, which, by the way, which we grant for the effort of consistency across the board. So essentially, what I have to say to you guys is start to realize they're giving us the information. This is excellent. We're excellent. We're excited. Everything that we're going to need to know to do. But the one part that we're going to have a hard time with is who is the energy advisor, what's their role, how do they relate to us, and part of where we're at right now, we are drafting that whole collection together.
And we've seen that. Excellent points. I'm not sure if everybody heard, but I think you were fairly loud. We basically have got the need for potentially more organization on the part of the energy advisor that we can rely on. I've got a slide here actually that compares the energy advisor and the energy model. I've got them uppercase, but the reason that it's uppercase energy advisor is that it's actually an actual title versus an energy modeler who, as you pointed out, is hopefully not just anyone, but isn't necessarily certified to be an energy modeler or to be doing that particular task. And that's just the basic, the nature of it. It's the same for a lot of construction aspects, right? Okay, so the energy advisor, and this is not intended as the only pathway. I know that the goal of the code and the way that it's written is essentially to leave it open, but we know that energy advisors are definitely a good way forward. But we don't want to exclude energy modeler, the lowercase, the loose term energy modeler from this potential compliance process. Okay, so they are the energy modeler or energy advisor, third-party consultants registered with a service organization licensed by EnerCan. They deliver EnerCan's EnerGuide Rating System, as well as a few others, the Energy Star and the R2000 program. But the EnerGuide Rating System, the ERS, is what's directly referenced in the BC Building Code as one of the compliance pathways. So we know that's an excellent match. So they are required to do the energy modeling as well as the airtightness testing. So we have that alignment, and they'll generally have the expertise and the equipment to do it. And as part of their maintaining their certification, they're actually submitting models to EnerCan for their review. So again, that oversight. And it's not that every single model is reviewed in detail and certified, but they are reviewed. And then there are audits periodically to make sure that energy advisor is still working and still technically in line. So that, as I said, the third party oversight is a bit of more of a confirmation that we're on the right track. Not necessarily yet a full professional or semi-professional organization, but that is, I would say, that's in the works from what it sounds like. Not part of this discussion here. On the other hand, the energy modeler is not affiliated with a service organization or the EnerGuide rating system, so they actually aren't certified to be able to provide any type of EnerGuide services, but they can show compliance through other means and through other processes in the BC Energy Step Code. They also can use other energy simulation software other than, I pointed out here, HOT 2000 is the program that energy advisors use. There are a few others, and the energy modeler may be using them. The energy advisor is an energy modeler, of course, but energy modelers are not all energy advisors. I'm saying energy advisors as much as I'm saying airtightness. Those two words are big. So you can see a pretty clear picture of maybe who you might rely upon for accurate, and detailed, and well thought out design information. But it's up to you to be able to implement the requirements through bylaws, policies that do restrict that. And in theory, it could be. It could be restricted to energy advisors if you're confident that service can be provided in your jurisdiction. Yes?
So as long as we get an energy modeler, we can meet the requirements for step code?
Yes. So they won't be showing it through the EnerGuide system. They'll be showing the TEDI, the airtightness, and the MUI. Just the compliance report, that's right. And there won't be an EnerGuide rating associated with it. Yeah.
One of the things I'd like to bring up too, in the other aspect of part 3, well, we for part 9 at the moment, but in the aspect of part 3, when you use an architect or a professional, there exists in their industry I'm not gonna say a sub-profession, but it's a sub-consultant level in their profession to be what's called an energy model. We do use that term in their part of their profession to have be identified as a lot more responsible person for compliance to part 3 of the building code. It's referenced in the PN guide relative to energy modeling. There's a whole role, not a whole role, but there's a whole perspective of how they do what they do. So what I'd like to make a slight little distinction in terms of an energy model is there and an energy model in part 3.
Sure.
There's an oversight role with the professional in part 3 on the energy modeler, not just where we have somebody that's capable of running a computer program and giving you the compliance report and say, here, go do it.
That's a great point. There are energy modeling, yeah, that's right. Energy modeling certification through the PNG program. You can be a kind of certified or named as an energy modeler. But this is a separate point where we have somebody doing an energy model, and they are an energy modeler. Okay, so the other part is, and this is where we get into the weeds with it on site, we have the airtightness compliance. Potentially on site at least, we pointed this out, you have to now confirm that we're going to reach airtightness, the airtightness target as per the design, starting from the design all the way through to construction, all the way through to completion. So maybe you've heard this term, the no-fail option. Maybe it's a new term I'm bringing up now. Step 1 is intended to allow for a bit of, again, that word practice and training to make sure that we are all on the same page in terms of testing and the goal, but not necessarily restricting or getting in the way of completion, because it's step 1. It's the first step towards energy efficiency. So with step 1, there are 2 basic compliance pathways in terms of airtightness. I'm going to touch on them here, but there are far more resources in the guide and beyond that at energystepcode.ca, as well as bulletins I'll point out. The first one, with step 1, again, step 1, airtightness compliance, the first one is through the EnerGuide Rating System. This is now using Energy Advisor. They're doing the airtightness testing, but they are using the as-built airtightness. That means that the goal, regardless of what the level is, that level of airtightness as per the design has to be attained, or they have to modify the building to account for if it's not as airtight. The other option is the 936.5 compliance path with the assumed airtightness. And that means that we can design for the airtightness, but regardless of whether it's met, we can still submit the compliance and reach completion. On the other hand, beyond that, step 2 to 5, you have to meet code minimum airtightness. And that means that you're testing it and you're showing that it's that airtight, or you're improving the airtightness. I would recommend maybe seeing if airtightness reports can be provided, especially from energy advisors if they're doing the testing. The basic information on the building info, the pressures, the airflows. It's a way of showing that that test was done and done properly according to the standards listed in the building code. And then the other thing is, if you see that these submissions are seeking very high airtightness or low ACH numbers, that there's some more review and oversight potentially needed, because it's step 1, at least for this currently. Step 1, we want to make sure that we can show and reach and test, but if we're looking for better than that right off the bat, you want to maybe pump the brakes a little bit there. So the EnerGuide Rating System, I'm going to go back here to the 2 options, just a quick summary of those 2 options for step 1. The EnerGuide Rating System assumes 2.5 air changes per hour. That's the reference house. That's the starting air tightness. And that's fairly airtight as a step 1 starting point. But the idea here is that we've got energy advisors who have a bit of experience and understand this concept, are making sure that design can account for that. And then they are showing, as they complete the building, that air changes per hour was met. If it's not met, then it does play a role in compliance. You now have to show that you've got other improvements, and the energy model of the building is still as efficient as it was originally designed. And that will be taken care of through as I said, the oversight from EnerGuide, the EnerGuide rating system. You won't be able to achieve an EnerGuide rating if the model isn't correct and you don't show the airtightness that was actually built. So in short, this step 1 compliance, although it's the first one, you still are using the as-built and you're having to achieve it. The 936.5 compliance pathway, again, that's the no-fail option. That's potentially more likely for someone who's just starting out or giving it a go, even with an energy advisor, but at least allows for a bit of flexibility. You're assuming higher air changes per hour, that is less air tightness because it's the first go. And you're testing it and reporting it, but you're not necessarily, well, you aren't having to repair if those aren't met. The assumed air tightness is the design, and you're proceeding with either 4.5 or 3.5, and regardless of the test result, that's the number you use. Where this is important, of course, is this little point here, that the assumed air tightness is actually less airtight than the reference house. The reference house, the one that we're assuming, we're basing our design off of and trying to improve upon, or match in step 1, has got an air tightness of 2.5, which is actually better. So the trade-off is that if you are assuming the air tightness and you're not having to comply, you are then having to offset that lack of air tightness with other energy efficiency improvements. So we are potentially building higher R-value walls or using better windows because your assumed air tightness is not as high, and you're restricted to that. And so you either have to do this no-fail option. However, there are some, like I said, no-fail but trade-offs, or you use the EnerGuide rating system and you aim for that air tightness and you achieve it. We could talk about this a bit more, but I'd like to proceed, and by all means, it's summarized a bit more in the handbook, and then there are 3 building information bulletins from BSSB. They're online, and they kind of break down all of this discussion in terms of how this compliance is going to work. In short, this is intended as a transition step. The goal, of course, is by the time we get to step 2, we've got air tightness that everybody is confident they can achieve and has to achieve. Your as-built has to match the design. And this is a transition to make sure that it doesn't restrict or put a hold on any buildings that are that are aiming for step 1, but it's a training exercise. It was mentioned by Andy there, the mid-construction air tightness test. That can play a role in showing compliance before we get to completion. I'll talk about that. That, in fact, we don't have to wait till the very end to see whether air tightness was achieved. We can do it mid-construction while we can still make changes. And we can see that if the building's on track or if not. Okay, air tightness, clear as mud, I'm sure, at this point. Any questions? Yes?
Maybe Andy can address how have you made it mandatory for people to handle mid-construction or test?
Well, we made it bylaw to achieve various step levels kind of throughout the years here.
What was the question, sorry?
How do I make it mandatory to do mid-construction? Basically, it's just written in the bylaw, like energy labeling is written in the bylaw, which is kind of harder to achieve because there's no step code labels, only EnerGuide labels. I think step code labels maybe are coming, but yeah, mid-construction, I incentivize it as well, so it's part of this incentive program. So when they get a permit, they get a permit reduction based on the fact that they're going to do a mid-construction test. Otherwise, they don't get the incentive. And it's gotten to the point where a lot of the builders that are building multiple and have done it throughout the years now that are scoring, well below 1 air chain, I don't make them do the mid-construction just because it's a time saver for them. Not that it only takes the energy advisor about 20 minutes to do a mid-construction test, but it depends on where the air barrier is located, because actually if you pressurize or depressurize the building too much, you can actually pull the poly right off the walls if you're using 6 mil poly as your air barrier. Versus I have a lot of builders now doing outsulation and the air barrier's on the outside and the insulation's getting further to the outside. Almost a lot of buildings now, all the insulation's on the outside. And it's just a surface cavity in the walls now. So it's quite easy to do a depressurization test. You can ramp it up right up to 50 pascals and get a true reading. And through that, I've actually discovered window failures, like manufacturer defects. Because the houses are getting like to passive house, like 0.04 was one of the houses I did a couple weeks ago. And it was actually, the problem was the manufacturer defects of the window closures was the majority of air leakage. So something you wouldn't really pick up normally prescriptive wise. But when you get into higher performance, like a lot of these builders now are claiming, we're only going to build step 5 houses. It's like, well, that's quite a claim. And if you haven't experienced an air tightness test, energy advisors are doing them all the time. So if you haven't, like, have one at a zone meeting or organize one. Like they have open houses where the energy advisor will do them in Kimberley. So a lot of the builders, like real estate agents, mayors and council, like everyone sort of has seen one now, because seeing is truly believing for air tightness, because it is sort of a little bit abstract when you talk about what's the difference between 3.5 air changes and 1.5 or 2.5. But we've actually had houses that are super airtight, and then we've had the energy advisor open a window or door to see what a code minimum, and like the air is blowing in there, papers are moving, people's hair is blowing. Like it's quite a difference between 3.5 air changes to 1 air change. It's quite a volume of air especially in a bigger home or something like that. So, but like I really recommend seeing is believing to see an air tightness test. And the builders, as soon as they see one and go through one, then there's buy-in, because they get to walk around and see where it's leaking and, oh, okay, we didn't do that correctly, or we could improve that, or things like that. So I don't know if that answers your question.
Kind of, I'm on board with the mid-construction testing.
Yeah.
Absolutely. I think it's an absolutely necessary step. My question is more about like the mechanism actually requiring it. Like for Kimberley, like I reviewed your bylaw. Is it actually written in the wording of the bylaw? It's
in a subtext in the bylaw now, more at a policy level, kind of around the incentive program, which isn't necessarily in the bylaw, but the step code is. So our incentive program is sort of the policy, but the policy to get your rebate sort of permit reduction fee is part of this mid-construction. Then you sign a declaration on the form. It's written right on the permit. Mid-construction is mandatory. So yeah.
So if somebody, I mean, just in theory, if somebody really didn't want to do that mid-construction test, they can say, I don't want the rebate.
Yeah, well, there's the risk then that they may get a notice on title though, because they agree to that as well. And a lot of them, usually when I'm paying, like, give me the bill, whatever it costs your energy advisor it costs, I will give you the check right away, because BC Hydro basically pays me to pay them to do a mid-construction test. BC Hydro has a really good grant program. If you haven't got on there, they will basically sign a form, declare what you're going to do, and boom, like $20,000 check that you can use for incentives. And the primary, they want to use it for mid-construction testing. So, another question?
While we were going through this development with the step code and stuff, this problem came up specifically from the current jurisdiction relative back to the industry. How do we know it's going to meet it at the end? Knowing at the end sometimes we might not meet it, knowing that at that point in time we're going to have extreme difficulty resolving that issue. So the mid-construction work was brought up, drafted up by energy advisors and other scientists, people in the business that know what they're talking about. In that regard, to have it adopt or have it used, it goes back to each individual jurisdiction, creating their own policy, procedure, bylaw to say how they want to implement this across the board. So in fact, if you do develop something, you want to take the action, this new construction for what's developed to the benefit of this purpose. So you can use that to be adopted in your policy, procedure, or bylaw. The other item relative to the construction report, which not so much the pushback, but the understanding of what this document is. As the compliance report states, is as built. That's a finale system where all hard data can be achieved and measured. Whereas mid-construction, you can't do it as collectively and as scientifically to confirm that this number that I get now will be the same number at the final. So basically, it's evolved to be a report to say in their best opinion that this substantially complies to where I'm going.
Well,
Yeah,
we'll talk about the mid-construction verification report. So that's another report actually in there. It's a formal report, not necessarily itemized in the code, but it helps with making this happen, making the mid-construction test happen, and other review of the mid-construction building. To go back to the compliance reports, the two there, as I pointed out, the requirements that have to be shown are listed actually in BCBC Division C, but the pre-construction compliance report and the as-built compliance report are kind of separate to that, and again, pointed out in green because they're optional. In fact, you could be using your own compliance report if you choose to create your own, but these are pretty excellent, and I'll show them here. This is the pre-construction compliance report. There's both a pre-construction and an as-built in the appendix with an example home. And the idea, regardless of what the actual building inputs are, the idea is that we have kind of inputs that you'll see and that you can be checking and kind of form the basis for the compliance and for showing that it'll match. I'm not sure, it's not very clear, unfortunately, probably from your view, but you can see there in Appendix A, I believe, let me think if I got the page right, 36. And so this commentary helps you see the most important items and what to check on. This becomes part of the plan check process, so that you can create the checklist and the step-by-step process for your submission review and before you issue the building permit. So this pre-construction report has all of the information. It's all theoretical, obviously. It's part of the design. It comes from the energy model. We have seen, I think Surrey is looking at, Surrey or Langley, they are considering having the energy model also be submitted, and then they've got energy model reviewers that are helping kind of check to see how the quality of these submissions kind of as the initial, as it's kind of currently brought on. That's not your requirement. That's not your jurisdiction to say that whether the energy model is correct. You simply can't. You won't be able to have the information. But this compliance report is a good start. You'll have the information summarized, review the drawings and specifications, make sure it matches. The meat and potatoes, as I said, is actually in this compliance report, the building information, right? The assembly information and the R values. So we're still talking about effective R values and mechanical efficiency, but it isn't referencing 936.2 or 936.4. It's its own, right? And so these numbers become the reference for the plan check and then eventually the site review. There's also additional information in the compliance reports that really help to solidify, make sure that everything is correct. But these last two, C and D, they show how the compliance is done. So you can see there in section D, it's essentially a check of the BC Energy Step Code. And as I pointed out, you can see there that it kind of notes what's used for the energy modeling. And then, as I said, some supplementary information that isn't necessarily step code related, but helps to make sure that the energy model is producing the numbers that you're looking for. One thing at the bottom here, the optional certification. It's essentially if you've got that third-party review, either it might be EnerGuide or Energy Star, but there's also other forms, as you'll see in the code. We see Passive House is a big one, using Passive House energy modeling and complying with Passive House instead of Step 5 and being able to show that with this certification. The labels, the certification can also potentially play a role in, as Andy pointed out, in labeling, right? So at the end of this project, either on title or labeling, maybe labeling plays a role in how compliance is shown. We'll talk about that a little bit. All right, so you've got your own process. This is the compliance review. Your own process, hopefully relatively aligned. We want to make sure that we're not reinventing the wheel every time. And where it's hard is that the building permit applications, they're going to be different houses, different approaches, different R values, different air tightness, different windows every single time, or more or less every time. And it's not just a matter of checking off R values. You're looking at a little bit more. You're looking at that compliance report and showing that it meets showing that it meets the BC Energy Step Code. It's confirming that it matches. Two important things to point out, of course, that your certification, just like all code items, doesn't necessarily mean that it is the best solution, right? That it's the ideal energy solution. There's probably better ways to do it, but that's not the input you're giving on whether the air tightness should be improved rather than the walls, or using thicker walls, or XYZ, a better mechanical system. If it's meeting the BC Energy Step Code, that approach is approved. The second thing, and comes up as a question a lot, is whether, because it's certified now to match any of the steps of the step code, whether it'll actually perform that way on a yearly basis. And the answer, of course, is no. Simply speaking, the energy modeling uses baseline conditions, and it's a very basic representation of the energy use of the building. It's not a guarantee of the performance in use, if you will. So the owners can't be expecting that necessarily that level. It depends on how they use it, right? So that's a big part, and that's not something that the Energy Step Code gets involved with. And that's not something that approval of the submission package guarantees. So just keep that in mind. Another point here on air tightness, again, with the submission, that you can really front load your compliance process for air tightness and detailing, so that by the time you get to construction, it's a little bit more straightforward. Now, this involves a bit more design and detailing, but it's highly recommended as a kind of preventative approach, if you will, for air tightness. Because if you have a plan, you're a lot more likely to be able to reach it. And if you're putting effort into it from the get-go, you're well on your way. In terms of on-site, I mean, that's nothing new. That's something every building official is, I'm sure, aware of. It's pretty straightforward, and it's part of the job. But, of course, the reference isn't the 936.2 to 936.4. The reference now becomes the compliance report, or a form of the compliance report. And any discrepancies are what drive whether it's rejected or not. If you've got a new wall, or you've got, part of the floor plan that's moved, obviously besides anything else, the other implications for planning or zoning, windows, placement, assemblies is probably the biggest one, assembly and mechanical systems, making sure that it's correct on site and matches the drawings. And then air tightness, right? A little bit less straightforward. You're now looking at it, visually potentially, but without a mid-construction air tightness test, it's a little bit more difficult to confirm whether it's matching or going to match. The other thing is that you won't necessarily be able to check all of these BC Energy Step Code requirements or the compliance with with the basic site visits. There may be a need for more during an air tightness test, or depending on the air barrier approach used as part of the air barrier review, or you've already got it covered, and you're confident you can, in the 3 or 4 or 5, whatever number of site visits there are, you can confirm all of these things. Pointed out here at the bottom, the mid-construction BC Standard Verification Report is, again, a standardized form that is best suited for the energy advisor to be able to use to complete a mid-construction air tightness test, note the number, note the conditions, confirm that the design is being built, and then submitting it as part of the compliance. And so not necessarily part of the BC, the bare minimum compliance requirements, but very, very useful in prompting that review. So we touched on this a little bit. Now we're talking about non-compliance. Everything's done. I'll go back and forth a little bit in terms of the flow, the flow chart. But now we're at the end here. Let's say we've got non-compliance. This is probably where most of the hesitation comes in, because while we can look at a lot of the things, the air tightness, especially for steps 2 onward, it's something that you're having to confirm at the end, regardless of how you've specified it, right? You can specify it and hope for the best, and you've designed for it, but it comes down to the test. And that test may be occurring later on, and for the as-built, it's at completion. So there may have to, you definitely want to have some sort of process built in for non-compliance. And the recommendation here, of course, is strong enforcement. This isn't the first time you've had buildings that don't comply. You've got processes for dealing with those buildings. Ideally, you can require that the building team puts effort into the air tightness to improve the air tightness. If other parts aren't met, then you can get an energy model to update the energy model based on what the requirements are, and see if there's maybe you need to add more insulation potentially. But especially air tightness, where you haven't been able to necessarily confirm it, strong enforcement is our recommendation. up to a point, right? So we see here in quotations, every reasonable effort, something like along those lines for a policy that doesn't pigeonhole the process, but it's still as strongly worded as possible. I could say that from our perspective, probably the big thing to counter this is to say that, you know what, with airtightness especially, when you put the effort in, it's definitely doable, and we have a pretty good track record from builders who aim for airtightness and achieve it, and then can consistently achieve it. Once they know what it takes, it's not become a big speed bump in terms of rollout for the step code. The as-built compliance report, that's kind of the last check, as you pointed out there. It's the actual, it's the way to check that you've got construction matches what's reported and what's designed for, and that's the kind of the last part of this compliance process. In terms of withholding occupancy, or I should say, there are other code issues that maybe you had to deal with, and it's not necessarily as obvious, right? You're not going to have a building that falls down, or potentially is a fire hazard, because it doesn't meet the energy step code, but it's still a code item, okay? Withholding occupancy permit, I'll leave that to you. I don't know. That's something that's definitely one of the most powerful things that you can use. But on the softer side, putting something on title or using labeling is another really good resource to say it's more of an honor system, and it impacts the marketability potentially, but doesn't necessarily restrict it from being occupied. Something to keep in mind. Okay, so this process, this is the recommended flowchart, not the only way to do it. I'm going to go through this relatively quickly because we won't have enough time for discussion at the end. If there is a bit, I think we're doing okay. So we've got the owner or the designer or the builder. They're in charge of the building design from the get-go. Originally it was design, submit, do a bunch of rework, and then get your building permit. But now, of course, the design involves an energy model. So you've got either an energy advisor or an energy modeler, and you're developing the design. And what's important here is that the design, you may have potentially some input from the building official as well. If it requires full submissions, I mean, this is, the process can only work as well as you have the ability to make it work. But if you can have something that's not just a submission and then a rejection and then a resubmission, it'd be great to have some sort of pre-construction meeting, if you will, or some sort of correspondence, so that this iterative process is a little bit smoother, because we know that you're going to be making some design decisions and then changes, and making sure that the energy model matches or it meets the BC Energy Step Code, but that doesn't mean that you're going to get it the first try. Okay, so something to think about. Other than that, though, we've got the compliance report and the building permit application from the designer and the builder, and then the plan check. And we've talked about this. You're reviewing the compliance forms to confirm that the design meets the code requirements, both basic code stuff, all of the fire stuff and the exits and safety, but also the energy side of things. From there, we're then, of course, building per the design. And as Andy pointed out, it's pretty much never that the design or that the construction actually matches the design perfectly. And so with that, you have site inspections, the typical site inspections, and deficiencies or things that have to change throughout the construction process. That's just part of this construction process. I don't think there's any time where you'll not have any deficiencies, or you won't have any changes. Maybe, as we get down the road and there's more confidence in the designs, potentially, but it's still part of this process. And so what you see here, though, is the energy modeler potentially involved in tracking these changes, right? Changes in areas, changes in R values. That has to go back into the energy model to make sure we're still on track. And again, this points out the role the energy modeler has in this process. One thing, this is where the recommended quality control check, that mid-construction airtightness test and the mid-construction verification report, that can be in the same, during the same period as these site inspections, to make sure that we have them looking at it again and not just coming at the end, because that might be too late. Keep going, building. Everything's finished, more or less at least. We've got the primary site inspections finished. We could say substantial completion, although we want to make sure that we're confident that the as-built airtightness is what's being tested. We don't want to have things taped over, polyed over. They still got poly for the paint stuff. No, we want to have it, all of the components in place that are for the air barrier and anything else that might affect the air barrier. So these two, the dark green box here, of course, is a code requirement, right? This is the as-built airtightness test, regardless of the step. And for step 1, we complete it, test it, report, and complete the construction, assuming that we've met the requirements. The as-built compliance report, again, comes into play, not necessarily a code requirement, though it plays a big role. And then the final check, and this is where the as-built can be reviewed versus what's on site versus what's changed. Step 1, this works. And if you've met the airtightness first try, absolutely. If that's not the case, or you're at a higher step and you need to make sure that you change the airtightness or improve it, I'm going to go forward. Then we have to proceed with more changes and a bit more of a back and forth to resolve the deficiencies for the airtightness. Like I said, for steps 2 onward, if the airtightness isn't met, as listed in the code, then we have to look at that. And potentially follow-up inspections, especially if there are substantial changes. If we've got modifying the enclosure or we're pulling things out. Hopefully it's not that involved, but it still may be needed. And then proceed with completion. One thing here, as I pointed out, the informational or compliance tool using labeling as a driver to say if you can show the label that you show with a label that you've met the code and then maybe other energy requirements or systems, then that helps with kind of a third party, if you will. Same final checks and then occupancy permit, or if there are things that have to be in place, non-compliance recorded, either on title or with another, an addendum to the label, if you will. So that is the process, a bit of back and forth, up and down, involving again that third role, the energy modeler. Any questions on this super colorful, super animated flowchart? Yes.
Just be talking about the energy label and stuff. Like at occupancy, would they have an EnerGuide label, or how long does it take to actually get and maybe I'll put it on there?
That's a good question. It's so the energy advisor through EnerGuide will be submitting their model, and it's, as far as I understand, it's not a very long process to be, they check that the model matches and it's correctly done. They issue the energy label, EnerGuide label. Other processes not necessarily as fast. I know Passive House takes a bit of time. There's actual on-site review. Those are probably the two that come to mind. I'm not sure about other energy labeling. Built Green, that's another one. That's right. Yeah. Not extremely long. I would say, yeah, it's probably something to keep in mind that potentially that delay, if it plays a role in compliance, then it's something to keep in mind because you have to kind of wait to see, if you will. I would say if you're looking for it, it's worth, a builder who's aiming for a label, they want to make sure they hit it or it was a waste of time. So they'll definitely go for it. Question at the back? No question. Okay. Yes.
One more. So if there is a change in mid-construction, like windows and focus like that, are you asking for pre-construction form, or are you asking for pre-construction form? Just kind of what are you looking for there?
Yeah, I would say that hopefully the mid-construction form can basically report those changes and show that it still matches. But if you are not confident or you want to have more info, potentially you could add it as a second thing to say, call it the mid-construction compliance form with more of the information that it's no longer pre-construction, obviously, but it's the same info to show that you've got the R values accounted for, air tightness potentially, and the energy model still matches. So that form becomes a big part of compliance.
I think there's sometimes I think the building official thinks the energy advisor's on site or aiding the builder during construction. That is not the case. That's why this handbook is sort of giving you the tools to still do your job during inspections. I've caught contractors putting in 4-inch flexible duct, for instance, on their HRV, and it actually would have failed the home to meet a step 2 home because you're supposed to be a 5-inch duct. So the efficiency of the HRV was gutted, and they didn't meet the minimum standards that they had to achieve at final. And the energy advisor would never have known that if the drywall was on. So like, I'm always, hey, like I look at the, the floor plan or the layout, and often changes or an extra windows put in there, and it's sometimes a big window, and sometimes for limiting distance you have to catch that anyway. But for energy efficiency, they have a certain window to wall ratio calculation on the form, and so it can affect that if he's already plotted in how many windows per wall ratio, and all of a sudden, oh wow, there's another giant window here because they wanted to look at something that was outside on their lot, and it affects the window to wall ratio. So I often forward it to the builder, or I often see a different R value go on the wall or a different U value on the window. So I often flag those and just send a quick email to the energy advisor, hey, just this might affect the final, just so you know, because the energy, the label on the window might be missing by the time he gets there, or the drywall will be over the duct, or he might not notice that window when he's just plugging in to do an air tightness test. I used air tightness. More questions. Yeah.
I was just wondering how this process, step code in its entirety, affects E277 and Z240 homes.
That's a very good question. I have this year about 4 or 5 even multifamily modulars. It's been quite a process for them to comply to step code because in the factory they say they're already certified, but the air tightness for them is I'm having the first ones do their first blower door tests right now, and I'm crossing my fingers, even though I saw them on site connecting the modules on the outside with the air barrier, and I doubt they're going to meet. So they're going to be a non-compliant build in my opinion, because their windows already came in and they didn't meet the U value, so they were already at a detriment. And most of these, I'm on the closer to Alberta, so I'm dealing with a lot of Alberta builders that I'm having to help along, which they're getting better. But yeah, the modular builders out of Alberta, I think they're going to make it personally, but we'll see.
What I noticed in my jurisdiction, which is low wetlands.
Okay.
Yeah. Same zone as this.
Mhm.
But, well, not quite. But people are turning away from stick-built homes
Right.
by modulars
Yeah.
because technically they don't have to meet this step code.
They do actually. They're not exempt from it. The 827 exempts. They're still factory built, so they have to comply to all. Like you still get a building permit for them. They have to comply to code, and air tightness is required, which they're actually maybe fighting or going to fight the province on, saying that there should be exempt. But they don't do any testing, so again, it's not apples to apples in my opinion. If they're claiming they're the same as a site or stick-built home, in all other respects, they're just built in a controlled environment, they should be better or better improvement for air tightness if they can do it in a factory when the wood's dry and they have all the balancing checks. I think it should be mandatory to do each module in the factory, and then they can maybe exempt at the final. But again, when they put the modules together, I was watching the guys, and they weren't the swiftest guys, taping the outside, and it was all ripped from travel on the highway, and it was like, how's that going to meet air tightness? And they're fully relying on their outside air barrier, because the inside poly is, I don't know how they're doing it, because it's all drywall, and it doesn't look like it's done very well.
Use that 240 homes still?
No. They're completely exempt from energy step code as far as I know, because they're exempt from building code, more or less. Is that like the mobile homes? Correct? No?
40 step codes.
Like, you can speak to Z240.
It's my understanding that Z240 homes are required to meet the insulation requirements in the location where they are, and the energy efficiency requirements in the location where they're being placed. I wouldn't consider myself to be an expert on that question, and I can reach out and check in with you later on that question. But my understanding, and we've received a lot of pushback from the Manufactured Home Association BC, MHABC. But yeah, they need to meet the code. And if your jurisdiction has stipulated step code, they need to meet the step code. That's my understanding. I'll check and I'll let you know if I'm wrong.
I'm not.
I just want something. I'm just wondering who's going to enforce this in 2022.
You will be.
So I'm going to protect these homes.
Well, if the province makes it mandatory, which Don will be speaking to later on the changes coming, but yeah, 2022 is projected to be mandatory. As far as I know, step 3. Yeah. Modulars, in my opinion, they're going to have to up their game quite a bit.
Significantly.
just because I've had a lot of the modulars, even they have to do a pre-construction model submit. They weren't meeting minimum building code, like for prescriptive, not energy step code, but minimum building code in a lot of ways. So they had to up their game quite a bit. And they did a lot of trade-offs with the energy advisor. I think it was 5 submissions for this one fourplex they were trying to do. About the 5th iteration of drawings that I finally got that I could approve.
So
Based on.
why don't we proceed with the last bit here? I'm just about out of time anyways. I appreciate the question on modular. That's really important to point out that we want to make sure we've got guidance and industry aligned on modular, especially we see that a lot more. So stay tuned for that. Hopefully we get kind of basic industry guidance out on that. The last few slides here, just an overview of that third section that you've got in front of you anyways, but I want to make sure we get through it. The principles of high performance buildings. A pretty quick summary of a fairly large chapter in, I'll point out here, the Builder Guide, the BC Energy Step Code Builder Guide, which is a much larger document. And the idea at least is that you can see what it takes so that you can understand if it's realistic. If the numbers you're seeing are realistic, get a sense. And you can only take that so far, but I think it really helps with making sure that the numbers you're seeing, they make sense to you from an energy efficiency perspective. So in this last portion here, we've got a summary of both the enclosure side of things, air tightness, overall form factor, talking about some of the other high performance design characteristics. Again, not necessarily strictly step code stuff, but maybe something to think about, especially as we get with higher and higher efficiency homes, they become more and more sensitive. And then also mechanical systems. That's a big one that's useful to be able to kind of quickly reference to see what kind of systems you might be starting to see in, especially, like I said, higher performance buildings that aren't using as large systems, electric systems, heat pump systems. And then, as I pointed out, the Builder Guide is also a pretty useful resource. You can see what the builders are referencing. We're going to be definitely promoting this guide even for builders. It's really useful for builders and energy advisors to see what kind of guidance you guys are getting, and they can take what they will from it. And then lastly, the appendix, appendix A, you saw the compliance reports. Appendix B, this is the actual summary of all the requirements in a little bit more easy to access format compared to the actual code. Stay tuned, obviously, for updates. You'll probably see there's a presentation here about BC Energy Step Code updates coming in December. It's just number changes from our perspective, but you can see that it's updated in there, or it's included in there, and it will be updated, so you can quickly reference it. This guide is available online. If you're not sure, you want to make sure you've got the most recent version, by all means, check out energystepcode.ca, and I think BOABC as well. Questions, discussion in the last minute or so of this presentation? Yes, at the front. Thank you.
I'd like the province to provide some guidance on the 877 thing.
On the list.
Could you repeat that over here?
Yeah, we're looking for guidance on 8277, the modular construction for provincial guidance on the code requirements and what they're complying with, whether it's energy as well as other basic building code stuff. Yes.
Our time from just a quick note to all those who have not already subscribed to the Energy Step Code website. They have updates coming every month or so. I have code update that just was talking about will be effective December 12th, so just watch out for that.
I think there's a presentation on the new code changes. I believe Don might be doing that today. No?
I think it's Zach.
Zach's doing one here as well.
Yeah.
On the new changes coming December 12th. There are some step code changes, so that be aware.
But nothing that changes the compliance in this discussion we've had today, at least, as far as I know.
More technical changes.
Anything else here? Yep.
Do the energy advisors have whatever kind of organization they're attempting to put together to formalize their professionalism? Do they have a website that identifies the places they work?
Places that they work?
Or the places they work?
The question was, do energy advisors have a website or a certification body that shows where they worked or the body of their work, I guess?
Well, what I'm concerned about, so we work in a regional district, right, and we put in 22,000 kilometers.
Right.
Right, implement this apparently. And the energy advisor that works in one part of it won't be the same energy advisor that works in another, likely?
No.
They meet equally people.
They do work with each other. A lot of them are QA work for each other, like quality assurance, so they would vet each other's reports.
What was helpful, I think would help, would be if they had a map that showed the energy advisor's certain parts of the reef.
That would probably be good, yep.
Versus other.
They're compliant to work in anywhere in the province, but they might be more familiar with one climate zone. I think if that map was created, the province might have a little shriek in their office of the lack of capacity that would be coming in 2022. Because I know my energy advisor, he covers all the way from Golden to the Alberta border to the US border to basically the West Kootenays. It's an incredibly large area he drives around and does reports for. But yeah.
The Energy Advisors Association, three of them have actually done that, where they have done a map and they isolated energy advisors areas and help maps between them. So it is created, I can't remember the website, but I can't get it for you today. But there is a place that you can go, you can go on the website, and you can find local TAs who are working in a particular area at their particular level. I think that's the only thing that I don't know if you want to introduce or not, level TA.
I'm not familiar with that, no.
Okay, and in respect to what we're talking about right now, we're talking about single family dwelling. You can have a TA that qualifies for a single family dwelling, the moment you put the secondary suite in it, it's not qualified anymore, you have to have a verb now. So the whole issue is we're all trying to work out, get it in the system, is what we're talking about right now, strictly for single family, the moment you put the secondary suite in it, it doesn't matter. Where you do roll on roll townhouses, still work on the basis of the unit itself. Second part is if you do the horizontal offset, where you have a horizontal unit, that goes into a word classification, different EA has to become involved in it. So on that website, I do believe they're gonna have their levels of qualifications for what they can actually do.
I really appreciate that input. Thanks very much. I wish I could give you a mic, but anyways, other than that, I think we're gonna call it. We're over time anyways. I appreciate all you guys' participation. Thanks very much.